Okay, everyone. Good morning or good afternoon. This is going to be our second attempt at a video. I'm using some different software this time, so hopefully that'll help out some of the blurriness that we had before. You should have another set of notes again to help you kind of um, get through this section, help you kind of organize your information. So if you'll look at those notes at the beginning, there's some definitions just like last time, some like definitions and information that you're going to need. That'll get kind of our our big idea out of the way. Then we'll work some examples, and then I'm actually going to talk about a way for us to get some extra practice um, that should help you kind of reinforce some of this um, and get automatic checks to your answers and step-by-step instructions along the way at the end of the lesson. Okay, so once I'm at the end of this, I'll talk a little bit about that opportunity. Alright, so we're going to continue our discussion about circles today. Um, and we're going to start off, today's whole lesson is going to be about angles and arcs. We're going to spend a lot more time on arc length than we are on angles, but they are interrelated. The two values are. So let's first talk about what a central angle is. Okay, so a central angle has the center of the circle as its vertex. So in this example right here, B over here would be the vertex of our angle. And if I wanted to talk about angle ABC, that is a central angle. And we can either think of this central angle as being the smaller angle, or we can also think about the central angle being this larger angle, this one that's larger than 180 degrees. But both of those are two central angles of the circle B, okay? Because it has a center of the circle as its vertex, and the two sides of that angle are radii of the circle. All right, so that covers central angle. The sum of the central angles inside of the circle, if as long as they don't share any interior points, right? They don't share any parts together. Like this circle you have over here that I circled. It has these angles 1, 2, and 3. They don't share any parts of each other. Well, just as you probably already knew, the sum of all of those measures is 360 degrees. Okay, so I think I've left my little degree mark off of that. Um, I'll try to draw it on. I'm having a little bit of trouble with that. That's what happens when you're trying to draw with your uh, draw on a laptop. But 360 degrees should be the sum of all of those things. So if I add up angles 1, 2, and 3 in that little circle, they need to add up to 360 degrees. And we're going to use this information to help us solve problems as we move through this section on circles. Okay, um, an arc. Let's talk about what an arc is. An arc is just one part of the outside of a circle. You can see in this circle Q down here at the bottom um, that I'm going to kind of circle in green highlighter here. It has two arcs, one arc in red and one arc in blue. Um, those two things are parts of the circle, not the whole circle. So an arc is a part of the outside of the circle. Central angles, that angle RQP, or if you wanted to think of it as the angle PQR, it is what is dividing this circle into two different arcs. Okay, more central angles that we have in there, the more arcs we've divided our circle into. Like the circle above the one I'm speaking about, the one that had the angles 1, 2, and 3, it had three different central angles, and those central angles divide that circle up into three different arcs. All right, every time we have an arc whose measure is less than 180 degrees, we call it a minor arc, okay, because it is smaller than half the circle. So in this case, the arc PR, we denote minor arcs generally by only uh, two um, 2 points, just the end points generally. Uh, it is a minor arc. Okay, so you can see the way I wrote that. It looks like just kind of like you do a line segment, only you do a curvy top to overtop the letters. And a major arc is an arc whose measurement is more than 180 degrees, and it's not just defined by the two endpoints, but we generally try to also find some point along the way, some interior point inside that arc. So this arc could be PSR. You could also define it as arc RSP. So that's a major arc because it is larger than 180 degrees, bigger than half of a circle. Alright, and a semicircle is an arc whose measure is exactly half of the circle, or 180 degrees. And we name it by two endpoints and then some other point on the arc. So if I had, this circle right here, and I had the points A, B, and C like that. And the reason why I have to have a third point is because I need to make sure, if I called it arc AB, how do I know which way I'm going? I don't know if I'm following this path or if I'm following this path. So it's very important for us to have that third point when we're dealing with a semicircle so that I know which way to travel. And that's the same thing true for the minor and major arcs when we are back talking about them. The reason I have to add in a third point when I'm talking about a major arc and why I don't include a third point when I'm talking about a minor arc is so that I know in which direction I am going. It is possible to define a minor arc as using more than two letters. That's just not standard. Okay. Alright, so this, if I wanted to handle this one that's in purple, I would call that arc ADB, and because its endpoints are kind of make up a diameter of this circle, and so therefore the measurement of that arc is measurement of that angle is 180 degrees. This is called a semicircle because it's half the circle. Alright, next let's talk about what it means for two angles to be congruent. Alright, two angles are congruent if their arcs have the same measurement, if they are so congruent arcs are arcs that have the same measure inside the same circle. So, or if they're congruent circles. So basically that means if like the angle that makes up that arc and that angle right here, angle 1 and 2, let's say angle 1 and 2 are congruent, then that would mean that arc FG is congruent to arc JH or HJ. Okay, so because I said that those two angles are congruent, then I get to say that those two arcs are also congruent since they're in the same circle. It matters that they're in the same circle because I need to make sure that the radius is the same. If I have a bigger radius, then I'm going to have a bigger arc if the angle is the same. If I have a smaller radius, then I'm going to have a smaller arc. Alright, and then we have a theorem that goes along with this. This theorem is called the central angle congruency of minor arcs. Basically, what they're saying is in the same or congruent circles, arcs are congruent if and only if the measure of their central angles are congruent. So I'm going to end up with a congruent arc in congruent circles or the same circle is if that measure of that central angle is congruent. Okay, also that means if the measure of the central angle is congruent, then the measures of our arcs are congruent. Remember that if and only if statement works both ways. Okay, moving forward. Now let's talk about what it means to be an adjacent arc. Okay, so adjacent arcs are arcs that share only one point in common. For example, in this circle W that you see over here, arc XY is adjacent to arc YZ because they share one point, the point Y. Okay, so that's our definition of what it means to be adjacent. Probably about what you imagined. Alright, so now let's talk about the arc addition postulate. That means if I've got basically the measurement, if I wanted to find the measurement of the arc XZ, okay, the measurement of that arc, then that arc's measurement is going to be equal to the sum of the two adjacent arcs that make it up. In this case, the arc XY and the arc YZ. And I think this should make sense. It makes sense that if I add up that length to this length, that would make the whole distance from here to here. I mean, it makes sense, right, that if I take those two pieces and add them together, that I get the whole. Okay, so that's all that arc addition postulate is saying. Alright, the last thing, the only thing really in this section that I think can slow people down is finding arc length. Okay, so you might want to put a star next to this one to be the thing that you really want to focus on, because I think it's the one thing that you might have trouble with because it has a formula involved. Alright, so I'm going to highlight this formula because it's the one you're going to use most often. I'm also going to talk about the other formula in just a second, but I want to spend more time talking about the one I've highlighted here in blue. Alright, let's say I'm trying to find the actual length of the arc. So imagine you've got this circle drawn on your page and you want to know exactly how long that arc is. Well, we found out the other day when we were dealing with the first section on circles that I can figure out how far it is around the whole circle. The whole circle is, if I want to find the length around the whole circle, I can do it by either 2 pi r or pi d, that's the circumference. But if I want to find the measurement of the arc, that's not the whole circle. It's only part of the circle. So what we need to do is we need to find out what percentage of the circle, basically, or what proportion of the circle I'm trying to find the length of, and I'm going to multiply the circumference by whatever that proportion is. Okay, so what I mean by that is in this case, what they're saying is that the length of my arc is whatever my central angle of my arc is. In this case, on this example here, L is going to equal to that x degree over 360. What that's going to tell me is how much, what percentage basically, of the circle have I completed. For example, if that angle is 120 degrees, for example, then I'll have gone a third of the way through my circle. So it would make sense that the length that I'm getting is going to be a third of the circumference if my angle is a third of the circle's angles. Okay, so we're going to find out what that ratio is, that angle over 360, the total amount of angles, and then we're going to multiply it by the circumference. Okay, and that is, in this case, it would be multiplied by 2 pi r. Okay, and that's how I'm going to find my arc length. So I'm going to find the percentage of the circle I'm looking at and multiply it by the circumference, which is the total length. The second formula is dealing with radians, and I'm not sure if your class has talked about radians in the past. radians are another way of measuring degrees. So I'm actually going to scroll down here a little further and have a little aside. Okay. So, and we talked the other day about how a circle has um, a sum of all of its angles, or maybe we talked about that earlier today, is 360 degrees. Okay, that is one way of measuring circles, and you're very used to measuring things in degrees. Okay, but I'm here to tell you that degrees are an artificial construct. Okay, we made those up. All right, someone did at some point in time. They thought it would be nice if they divided up a full revolution into 360 units, and they called those units degrees. All right, but mathematicians traditionally use a different way to measure angles. Okay, whereas we also will use degrees sometimes. Okay, which is the thing that you're very familiar with. We will also use these things called radians. So just like you've learned that 12 inches is 1 foot, when you do conversions or whatever, right? And then that can help you do conversions between inches and feet. 360 degrees is 2 pi radians. So that is why, if you look up above here, you're going to see that the other way, little typo, the other way of measuring arc length is if they give you your arc or your angle in radians. If they give you that angle, that's probably what I should have said this instead of saying arc, so I don't want you to get confused. If the measure of that angle is given in radian, then I'm just going to exchange the 360 degrees for 2 pi, which is its equivalent in radians. Okay, just some quick facts. That means that 360 degrees is 2 pi. Then that would mean that 180 degrees is equal to just pi by dividing both of those things by 2, or 90 degrees is equal to pi over 2 radians. And one thing I'll say is radians technically are unitless. So that's the reason that mathematicians like to use them. When you move up in your math, eventually when you get to calculus, you will notice that we don't deal with things in degrees anymore. We only talk about radians. So I don't want you to stress too much about radians, but just kind of becoming aware of them and familiar with them now, just knowing that they exist, and maybe knowing this relationship, all right, that 360 degrees is equal to 2 pi, or if you'd like to instead remember that 180 degrees is equal to pi radians, then that would be something you might want to stick into your brain back there to hold on to for later on in your mathematical life. Okay? All right. So let's go through some examples so that we can see how we're going to put all this stuff to use. All right? So our first example, in example 1, the first part says, for all these three things, we want to find the value of x. And in this first circle, in this circle for part A, I see that they've given me these two angles of 165 degrees and 145 degrees, and I've also been given x degrees. Well, I know that if I add all of those three things up, I need to equal the total amount of the circle, which is 360 degrees. When I add up 165 and 145, I get 310. And when I subtract 310 from 360, I get that x must be 50 degrees. So for example A, I found x by knowing that the sum of all of my angles needs to add up to 360 degrees. Okay, let's talk about the next one. In B part, I'm given an 85-degree angle, a 40-degree angle. Oh, and that little symbol right there I know means 90 degrees. And then I need to find x. So I know, again, just the same way I did last time, I know that 85 degrees plus 40 degrees plus 90 degrees plus x degrees needs to equal to the entire circle, which is 360. 85 plus 40 is 125. 125 plus 90 is 215. And so when I subtract 216 out of 360, I get 145 degrees. And then lastly, but certainly not leastly, we have our third example. Okay, this circle F. Circle F again has a 90-degree angle over here. So I have 90 degrees plus 135 degrees plus x degrees. That needs to all equal 360. Kind of ran out of space there. I'm going to say maybe I'll erase part of this. Alright, so that means 360 degrees is equal to 225 degrees plus x when I add those two together. Subtract 225 and you get 135 degrees is equal to x. Alright, so hopefully this has helped you kind of figure out how we might start using that idea that the sum of all the central angles needs to add up to 360 degrees. Alright, that's what that whole set of examples was about. Let's look at the second set of examples. They tell us that GJ is a diameter. Alright, remember in this class you can't take any assumptions. Okay, so that is a straight line. It is a diameter. I want to identify each arc as either a major arc, a minor arc, or a semicircle. So first of all, arc GH. What do you think that this arc is? Do we think that this is a major arc, a minor arc, or a semicircle? GH. Well, first I have to decide which way to go. Am I going to go the long way or am I going to go the short way? And how do I know which way to go? Well, remember earlier when it's just listed with two letters, I'm going to be going the short way. So that is the way I'm going to go. Is that going to be a minor arc or a major arc? That's right, it's minor. And what is its measurement? Yep, it's listed on the thing. It is 122 degrees. Alright, now let's look at the other one. It says, hey, find GLH. So I start at G, I follow through L, and go till I hit H. That's all of that. Well, since I found that GH was 122, and I know the whole thing's got to add up to 360. First of all, I know that this is what kind of arc, major, minor, or semicircle? That's right, it's a major arc. Oops. And its measurement needs to be whatever 360 degrees is minus 122. Because it needs to be basically what's left of that circle. So in our case, that is 238 degrees. Alright, so hopefully that feels pretty good. By the way, if you're wondering some that were semicircles, you could have either talked about the arc GHJ, that is a semicircle, or if you want to do the other half, you could say GLJ. Alright, let's go into another set of examples. On this one is one of those just like reading a graph ones. so get used to this to get ready for the ACT, a lot of reading graphs. Alright, this one's a pretty simple one. It's just a pie chart about female participation in sports. But we didn't even really need to know that to answer the question, so it's kind of silly to me. But if you look right here, they're just asking for the measurement of CD. Alright, so the measurement of the arc CD is right here, and that measurement is 18 degrees. They gave it to me. The next one they're asking me for is BC. Alright, and then that measurement is measuring also 18 degrees. So it turns out arc CD and arc BC are congruent arcs because they're arcs that have the same measurement in the same circle. Okay, hope you feel good about that one. Example 4. I want to find the measurement of these various arcs in this circle. First one I want to find is AED. So I'm going to follow it around. Remember how I told you earlier, some minor arcs we do use 3 letters to discuss. So just because you see 3 letters doesn't mean you should automatically say it's a major arc. Alright, they want me to find the measurement of this one. So let's look at the angles that make it up. Yep, the angles that make it up are 63 degrees and 90 degrees. And since I know from earlier, there's that postulate about the measurement of arc lengths that are adjacent to each other making up the whole, I know that the measurement of AED is equal to the measurement of AE plus the measurement of ED, which means that I've got 63 degrees plus 90 degrees, which, when I put my brain to use on those numbers, gives me 153 degrees for the measurement of arc AED. Alright, next we want to find the arc ADB all the way around. Wow, that is quite a distance. Alright, to figure out this one, I need to also think about adding these things up. So here's something I know that I can break this apart into. I'm going to start using my brain, right? And I stop and I stare at this thing for a little while, and I see that right there I have a diameter. So that means the measurement of this part right up here that I'm kind of highlighting in purple is 180 degrees. And what's left for the rest of it is 63 degrees. So the measurement of ADB is 180 degrees plus 63 degrees, which is 243 degrees. Alright, so that was fun. On to example 5. This is where we're going to start talking about arc length. Alright, so I want to find in each one of these circles, I guess except for the last one, I'll have to apologize. I stole some of these examples from another person, and I didn't realize that example C did not have an X or a Y in it, or a Z or a Y in it, excuse me. So we're just going to pretend that A is a Y and B over here is Z when we work this problem, okay, when we get to C. Alright, so I'm looking at right now A. If I'm looking at the part A and I want to find the measurement of ZY, I know that's talking about the minor arc because they're only dealing with 2 letters. And if I want to find the measurement of an arc, what I need is I need to find out the angle that makes up, the central angle that makes up that arc. So this length needs to be equal to 75 degrees over 360 by putting that measurement of that central angle into my little formula, times the circumference of this circle. The circumference of this circle is going to be 8 pi, 2 pi r. Basically, I double the radius and multiply it by pi. Alright, remember I told you that oftentimes we should try to leave pi in our answer. That's the best way to leave things. So unless otherwise told to, I would leave my pi in there. But in this case, the instructions very clearly say to round to the nearest hundredth. Okay, so it is important sometimes to read the entire instructions on something so we can get to our answer. So I'm going to pull up this little calculator here and we're going to do this. 75 divided by 360 is a number, and I'm going to multiply that by, since I don't have a pi button on this particular calculator, but hopefully you do on your scientific calculator or your whatever calculator you are using, I'm going to multiply this by 3.14159265358979. That's way too many things, but I'll stop it there because I want to be really exact, right? Okay, so I'm going to hit enter, and I get, oh my goodness, that was times pi, and I need to multiply that times 8. So that gives me an arc length measurement of 5.2359. So I'm going to say to the nearest hundredth, I got to round up. That's going to be 5.24. Alright, let's look at the next one. We're going to try to find this measurement right here, zy. Similar scenario. I know the angle, so I'm going to find that arc length. I would need to say that the arc length is equal to that angle over 360 times the circumference. This time they gave me a diameter, not a radius. So instead of using 2 pi r, I'm going to use pi times the diameter. Oh, by the way, I should have made, I forgot one thing on that last problem. So before I finish this one, when we look at the other one, they gave us units on here. They told us that that radius was 4 inches. So that means that arc length that I found, that 5.24, is 5.24 inches. I got to keep my units in the problem. So we'll keep that in mind in this next part when we work through it. Alright, so let's see. I have 130 over 360. I need to multiply by the circumference, which is going to be 10 pi centimeters. And when I put that into my calculator, right, 130 divided by 360, right, times it by 10 times 3.1415926.535, I get 11.34. Okay, so again, this is now 11.34 watts. I hope somebody answered me. Centimeters, that's right. Okay, good. Gotta make sure you're paying attention now. Alright. Last example. Yay! Alright, we have for YZ, we know the angle. That angle is 120 degrees. So my arc length is 120 degrees over 360 degrees. And I need to multiply it by the circumference. So remember that's going to be, in this case, 2 times pi times the radius, or 16 pi feet. So I'll do 120 divided by 360 times 16 times pi. And I get 16.7, if I round it, 6. Feet. Alright, So hopefully this section feels pretty good. Um, hopefully you feel really good about the material in it. It's basically the sum of the measures of the angles are 360 and the formula for arc length, which we've done a few problems on now. So you shouldn't have any problem trying to work some of the odd problems in your geometry textbook in section 10.2. Alright, so what I would do today with the whatever time is left in class is go to section 10.2 and try a couple of the odd problems from a couple problems from each section, alright, and see how that goes. Now what I want to do for the future so that you can have an easier way to kind of go through these things and get help if you get stuck on a problem is I want all of you to be able to go sign up for Khan Academy. Okay, if you don't already have a Khan Academy account, I want you to go get a Khan Academy account. It's very easy. You go to khanacademy.org. Okay, you'll sign up for an account. It's very simple. It's free. Very easy to do. And by the way, since all of you have taken the PSAT already, you can link your account that you used for the PSAT into Khan Academy, and it will give you individualized review to be able to help you score higher on the PSAT for next time. You want to kind of be working towards scoring higher and higher on it so that you have that opportunity to become a national merit finalist. Okay, that's how you get huge scholarship money. So really, if you can practice it a few more and get individualized returns, and you can really make your score a lot higher. It also will help your SAT score when you take the SAT and your ACT score when you take the ACT. Okay, but if you'll go make an account, please go make an account. Once you do so, you'll go to your profile. This is what your profile will look like. So here's mine. Okay, and when you get to this page, okay, you can scroll down. You see all these things. It'll tell you what you've done, what kind of badges you've earned. Okay, how many energy points you've gotten. You'll get energy points for doing videos or completing lessons. But you'll see up underneath, and I'm going to zoom in a little bit because I'm not sure what the resolution is like on y'all's screen. But if you look, here's the top of the page. If you look down here, there's these little tabs on your profile. And one of them says coaches. I want you to click on coaches. And then if you come over here to where it says add a coach, I want you to go into this box right here and you need to type in the code that is right here on this page. YGNXFN. Okay? That's YGNXFN. It's sitting here right in front of you on this page. I bolded it and everything so you can see it. Okay? This is the code I want you to put in. This will put you into a class that I've created on Khan Academy where I, Mr. Daniel, am your glorious leader and coach. Okay? And what I'm going to do is I'm going to assign things related to the problems that you're working. Okay? Also, even if I have not assigned things to you, you can use Khan Academy because what I have done is created a very special thing for you. Okay? I have created in Khan Academy, alright, I've created let me get to it. I've created a mission for you, okay? I've picked high school geometry as your mission. So when you log in and you go to your learning home, which is where you will generally end up, you won't have this teacher dashboard like I do. One of the things you will have is you will have missions that you can go to. So one of the things you can come over here to subjects, you can come to geometry, and you're going to actually have missions that you can go and work after. Okay, so when you click on this and it loads, you're going to be able to work through geometry things. So if there's anything at all that you've done this year that you did not feel very confident in, okay, lines, angles, stuff on the coordinate plane, stuff dealing with triangles and similarity, or congruence, any of that stuff that you've done in the past, or quadrilaterals, the unit you just went through, right? If there's any of that stuff, or transformations, that unit that apparently y'all don't know as well as you thought you did, any of that stuff. You can click on these things. There are videos and there are practice problems. And if you get stuck on a practice problem, you can ask it for help, and it will give you a step-by-step hint, and eventually will show you how to work the problem completely, but it will only give you a little hint at a time so that you can try to work the problem yourself. Okay, this is a great way for you to get help on your own and be able to make sure that you are doing the right things. Okay, so I highly recommend you do this. Your homework is to, before the end of the day Monday, so before Tuesday gets here, for you to go to Khan Academy, sign up, and join this class so that you can begin working through some of this geometry stuff. I kind of would almost go ahead and recommend for you to go ahead and try some things. There are some things that are directly related to what we just talked about today. If you go under circles, okay, you will see over here on the left, it has some things related to the measures of arcs, arc measure, okay. You'll also see a thing on arc length, okay. So both of those things are things that we have talked about already, and you would be able to go ahead and practice some of that information on your own to see how you're doing. Okay, highly recommend you go and do that so that you can become even more successful in this class. All right. I know I haven't left you with a whole lot of time left in the class. This video went a little longer than I expected, but I know that this is going to set you up better for the future by using that Khan Academy. All right. Hope things are going well. Good luck, and we'll see you next time.